Are you wondering why your 3D environments look like a generic video game while Naughty Dog's look like an absolute cinematic masterpiece? Most students and inexperienced artists think the secret to The Last of Us Part 1 is massive polycounts and having a large team working overtime on minute details. But it's actually the exact opposite. In reality, the asset's topology is quite conservative. So what is their secret? They rely heavily on shaders for adding details. By shifting the entire production weight away from high polycounts and onto extremely advanced material layering, they manage to push the limits of the PS5 without blowing their frame budgets. Today, we are looking into the actual pipelines of principal artist Matthew Trevelyan Johns and senior environment artist Julian Elwood to get a solid understanding on how Naughty Dog built this world. This video is a breakdown of production secrets that most schools completely skip. First, we'll look at the vertex density used to structure modular assets for perfect vertex paint blending. Next, we're diving deep into advanced shaders, including a step-by-step breakdown of an incredible multi-layered parallax occlusion ice shader that fakes meters of physical depth. And finally, we're uncovering the genius pipeline that saved Naughty Dog weeks or months of manual modeling, a custom procedural Houdini tool that auto-places individual bricks and calculates erosion along destroyed walls in a few clicks. If you want to transition your workflow from a hobbyist to a studio-ready professional, pay close attention to how these material layers interact. Let's start by stripping away the textures and looking directly at the wireframes. Once more, we look at the work of Matthew Trevelyan Johns as the principal artist was responsible of expanding upon and developing new art pipelines that would help empower the environment team to create a visual experience that could truly harness the full potential of the PS5. For this new version of the game on the PS5, the team tried to add environment storytelling throughout the space, giving previously empty rooms more clearly defined purpose and creating more unique props to fit the narrative. The artist is showing this wireframe shot of environment to show that the polycounts remain fairly conservative for assets. They tend to rely more on texture and shader work to convey detail, which is why topology is spread more evenly. The artist tried to treat all areas like mini vignettes, imagining the player hiding here for a while, having the time to take in the details, the cracked concrete, individually modeled leaves, slightly crumbling of the edge the window rests on. Their in-game wireframe view isn't so pretty as in other game engines, but edge thickness also denotes polygon density, and so it can be a useful debug. On the ground here, you can see how useful large alpha cards were supporting the leaf models and blends. Building on the work done by other artists, Mr. Trevelyan Johns remodeled many of the hero elements, like this bar, so that they could take advantage of the brand new trim texture shader pipeline he had been working on specifically for The Last of Us Part 1. Here you can see a little breakdown of the BRDF passes. Color and roughness are the two that the artist spent the most time balancing. As you can see, the roughness is a very important part of realistic looking materials. It does require much more work than what most school students realize. The meshes are divided to provide good topology that will allow the artist to paint vertex colors to blend the multi-layered shaders smoothly with no sudden, abrupt transitions or stretched blends between vertices that are too spaced apart. Still by the same artist, here are some advanced materials layering that are using complex shaders. During development, the artist often jumped in to help out on more complex looks, areas, or shader effects. In the Deer Hunt section, he took on this large area of ice as it presented a great opportunity for some special shader effects to really push the PS5. He wanted to create the illusion of real thickness and depth to the ice, with the stone riverbed distorted but still visible a meter or so beneath it. Rosie Fu, which is an amazing technical artist, worked on the runtime shadow code to enable seamless shadows as they were cast onto the separate snow and ice shaders. The ice shader was complex and initially was not fully supported by the blurred runtime shadows. The illusion of depth was created using multiple parallax occlusion effects to simulate varying crack thicknesses. The broken nature of the cracks allowed the artist to get away with minimal layers in the parallax function, reducing render cost. The subtle cracks, chips, and surface irregularities were handled by a very low-intensity normal map. And roughness values remain fairly low, with slight variance here and there to add some interest to the screen space and cube map reflections present. Some of the textures he created using Substance Designer. He referenced a nice ice material from a textures resource online before adding all of his own elements and shader-specific details. He also often go into Photoshop to add additional final details. He used large-scale overlays to create darker values and to interrupt certain crack lines on the surface of the ice. This helped break up the repetitive nature of the shader and also helped with the illusion that the ice had varying thickness. Here's a breakdown of the layers. First, the transparency refraction layer, where the height map is used as transparency. Then, the parallax cracks, height map plus diffuse. Crack line definition, using the diffuse only. Parallax cracks using the height map and the diffuse. Crack line definition, using the diffuse only again. The surface detail and crack definition, using the roughness and normal. Then, the overall brightening of layers using levels adjustment. Fake depth, using large-scale AO used as multiply layer. Now we see the masking of some cracks to avoid repetition. Fake depth, using large-scale AO used as multiply layer again. So this is obviously a very complex shader that requires a lot of tricks to make a good-looking material and keep everything under budget. If you're learning from these videos but are still struggling to put everything together into a full environment, that's exactly why I built my full course. You'll build the entire scene step by step in real time, understanding composition, scale, materials, and lighting, so you can apply the same process to your own worlds. These environments were created by students using the same workflow you will learn here. It's designed for artists who already know the basics and want to create a professional portfolio work, not just isolated studies. This isn't about learning tools, it's about learning how professionals build environments. If that's where you're trying to get to, you can check the link in the description. Next, we will look at the work of Julian Elwood, who found some time to integrate a little Houdini into the pipeline for this project. Throughout Outskirts, there are many destroyed brick buildings, and he decided to use Houdini to construct rapid booleans and auto placement of bricks along destroyed wall sections. This allowed for rapid iteration of complex destruction areas, all in Maya's interface through a Houdini plugin. So this is the Brick Wall Destroyer 3000. It features procedural insert brick scale and placement, primary, secondary, and tertiary detailed booleans, grout booleans, and erosion depth. Here we can see the insert brick detail variation, placement features, scale, and rotation. Here we have various rapid iteration examples. Here we can appreciate the final result in the game engine. And here are a few more screenshots of the final version in the game. So we can see how this tool was a must for such a production. It probably cut on the production time of the environment art team by weeks or months. Putting together such a tool and having plugins to make it work seamlessly between Houdini, Maya, and the game engine does take some time in pre-production. But once it is in the pipeline and ready for everyone to use, this is a must for a project that is set in a post-apocalyptic world where destroyed brick walls will be everywhere. Thank you to the artist and to the studio to have shared all of these insights with everyone that wants to learn how the very best games are made. I'm happy to introduce a new partner of the channel, Bundle Foundry. You can get several tutorials for a very good price here. The current bundle that is still available is called Become a 3D Artist Mega Tutorial Bundle. Several bundles just launched. You want to check this out. Check out the price also. This is great value. This is a great opportunity to level up your skills at a great price. Links to the bundles will be in the description. Seeing how Naughty Dog pulls off these technical magic tricks is incredible. But the real question is, how do you actually apply this to your own portfolio? If you want to transition from a junior or hobbyist artist to a studio-ready professional, Your portfolio needs to show more than just pretty renders. Studios aren't looking for artists who don't optimize their assets properly. Adding more geometry when vertex painting will be needed to blend materials to add storytelling elements, and keeping more conservative polycounts where it is less needed is something that will get the attention of recruiters. A great environment artist has to be a designer, an architect, and a tech artist. Your work has to look good, but it must run at 60 frames per second. Shift your focus toward advanced material and shader work. Use smart topology spread evenly for vertex blending, and let your roughness and normal maps do the heavy lifting for micro details. Work on your roughness maps. I cannot overemphasize this one. Most school graduates skip that entirely. You can make yourself stand out if you're putting more work on your roughness map. Don't just build assets, build pipelines. Whether it's a vertex blending shader or procedural tool, focus on creating modular components that can be shared, reused, and iterated on rapidly. Even if you're working alone on your personal project, this is what many recruiters are looking for. That's the best advice I can give you. This is exactly how I got my job in a AAA studio. I will make a video on this topic soon. A massive thank you to Matthew Trevelyan Johns and Julian Elwood for sharing these incredible breakdowns with the community. I'm also offering a AAA portfolio checklist that might help you figure out what's important for employers when applying for a job. The link is in the description. And a quick thank you to the members supporting the channel. Your support helps make these videos possible.